Hi, this is Jim McGregor back with another TIRIAS cast. I'm joined by my esteemed colleague, Kevin Krewell, and
Hello.
he recently attended the Marvell Analyst event. And typically they've covered everything, but Kevin, you were telling me they didn't really cover everything. This was more of like everything else we've seen recently, an AI event. So can you kind of give us an overview of it?
Sure. Yeah, officially it was called the Marvell AI Day 2024. Um, but it was about the custom silicon for data centers. They were very much focused on not standard off-the-shelf products, but customized products, and mostly for the hyperscalers. Part of that was they announced just previously, the week before, a 5-year strategic collaboration with AWS for custom AI silicon. That's a long commitment and a public commitment to working with AWS on building, basically Graviton and Trainium type of ASICs for AWS, and that's a really good strategic deal for Marvell. In addition, Marvell has a design win working with Meta to develop a very custom NIC just for Meta's needs. And that was pretty much their focus of the conference. Marvell has other areas in memory storage, automotive, consumer, and those products. There were some sessions in breakouts, but that wasn't the main topic. This was really about custom designs for the data center, mostly for the hyperscalers.
Now, I have to ask you because, I mean, Marvell first took this step towards custom silicon with Thunder, with the Thunder X series,
Yeah.
where they had developed a standard processor based on the ARM architecture,
Mhm.
and then decided that, most of their customers want custom solutions. So, or derivatives of that.
Right.
So, are a lot of what are these custom solutions? Are they derivatives of Thunder X? Are they processors? Are they accelerators? Are they NICs? What are they?
Yes. They're everything. So one of Marvell's key, and I wish I had the slide to put up for you, is their collection of IP that they have that they can build all these things for the data center. They have the SerDes, they have the networking controllers, they have hardened ARM cores, uh, and the list goes on of all the IP that they have that they're ready
A
to
lot of
put
this came from
there.
Cavium.
A lot of it came from Cavium, but it's a mix of stuff. They've also bought a part of was IBM, and then got
Hmm.
sold to Global Foundries, and then that brought in. That's also part of this deal. Some of the IP they have, um, but in addition, they take IP from some of the hyperscalers and integrate it together. So, like in the case of these AI accelerators, the AI cores are not Marvell's cores. They're the vendors' cores. The vendors are bringing the AI part of it. Marvell is adding the interfaces, the SerDes for networking and for memory. They're adding the hardened ARM controllers. Not all ARM. I did press them on that. They do have some RISC-V designs as well, but they're soft RISC-V cores. Going back to their their history, they were a strong ARMS vendor, but they're not exclusively ARM.
Well,
Um,
and actually, if you go back even farther, some of the original Cavium stuff was MIPS. So yeah, they've
Way
kind of
back when,
spanned
yeah,
all the architectures except x86.
yeah. Yeah, nobody really. x86 is just basically AMD and Intel. So some of the interesting stuff they've been doing with this, uh, they're building most of their work is foundry is with TSMC.
Hmm.
Um, and they've been doing some of these advanced CoWoS designs with multiple large dies, and they talked about some of the limitations of how big they make these packages, and some of it has to do with the size of a particular carrier that may limit the actual maximum size of a 3D ASIC or 2.5D 3D packaged product. They also talked a lot about 3.5D, which is basically multiple 3D stacks on one with one interposer on the bottom. Some of the interesting things they're doing in this area was they are building something really unique, and that is a custom HBM memory. So they're not building the memory, but they've got on board the key HBM memory vendors. Samsung, SK Hynix, and Micron are all supporting this effort. So what they've done is, on all HBM memory, there's a base die, and that base die is actually a logic process and a memory process, and that has the controllers for the memory as well as the interface to the ASIC or the processor or the GPU you're talking to. So they've done a custom version of the bottom die with their own SerDes. So they have a higher throughput, faster SerDes than the standard JEDEC form. In addition, they get 33% more capacity. They can do a higher stack. There's a 25% savings in the real estate. That's the real estate on the ASIC the memory's talking to, which for all the SerDes have to talk to it. And then there's a total of 70% savings in power.
Wow.
So this is a real advantage to vendors where even though they're it's a Marvell to Marvell interface, so the memory has to be done by Marvell and as well as the ASIC, but they have multiple memory vendors they can deal with, so they can deal with any of the three major HBM vendors. And if you're already committed to Marvell doing your ASIC, well, if Marvell did the memory, that's not a bad deal. As long as you can get better throughput or more capacity or lower power. And power was a continuous theme along the way. And that's part of where Marvell actually was Marvell was sort of pitching the story of why hyperscalers want to build custom silicon. And the main reason is TCO, total cost of ownership. Even though there's upfront cost of building these ASICs for AI that that they have to do, there's an NRE that goes to Marvell to build the chip, to design it and produce it. But the long-term benefit will be lower power, higher density, more optimized solutions. One of the Marvell's points was that most of the hyperscalers have deep stacks. They have very specialized requirements, and therefore they want to build their own specialized silicon. Sometimes initially for in-house, just even not in-house use, not
Yeah.
just for cloud provider as cloud services. And though they know their software and they know their needs better, and they wanted and the hyperscalers want to build something optimized for their needs, which lowers power and can improve density of compute, which leads to a lower TCO.
So what about the logic to logic interconnect? Are they doing a custom there, or are they using, because I mean, obviously we have PCIe, we have different interconnects. We've got UA Link coming up. Obviously, NVIDIA has their own custom solution. So what about that logic to logic to really increase performance across the platform?
They are doing a lot of stuff there. It's so interesting. They have their own, like I said, they have their own SerDes for fast interfaces, but they are working within the standards.
Okay.
They were involved in the very early stages of a bunch of wires at the OCP standard, and they're fully on board with other the what's I'm blanking on the standard for chip to chip, chiplet to chiplet.
CXL?
CXL. No, CXL is processor to connection. No, OCP, Nick. No, no, no. What am I blanking on it?
That's okay. Well,
Yeah,
matter of fact, they're working together now on UA Link, which
yeah,
is going to be a derivative of
yeah,
InfiniBand from AMD.
yeah. So they're from that point of view, they're still working mostly within the standards.
Okay.
So, but they are really also another big point is in addition to the chiplet stuff and the chip designs, they're very much into the networking. And one of the things they're seeing is that there's a data center interconnects where some of these problems, especially the training problems, are so big, not just one data center is enough. You actually have to network multiple data centers together. So they're working at higher speed optical links to allow what they call DCI to be more practical, and that's to run fiber between distant data centers to aggregate the data center compute for AI training.
Well, one of the issues with the data center is you often get capped out by thermals and power, not
Yep.
just by, what you can pack in the data center. And in a lot of cases, as we're seeing people go to these more advanced platforms, they're using a lot less room within their data center, but their data center wasn't built to handle more power or the thermal load that's required for these systems. So I can
Yep.
see that. I can see the need. Definitely optical between data centers, optical within between racks, and definitely even optical within racks. I'm
Yeah.
kind of surprised that nobody's and you can comment all you want on this. I'm surprised nobody else has re-looked at the trays because pretty much all the servers today are trays. I'm
Hmm.
surprised nobody's taken a harder look at doing blades again because even back to compact PCI and advanced TCA, um, at Motorola, we were doing optical interconnects in the backplane. They weren't cheap, they weren't easy, but we were doing it.
Well, yeah, one of the things that they're also working on is low power optical. So those
Hmm.
are lower power optical solutions for in rack use. So that's coming along. There's still a lot of copper going into the rack inside the rack. And they're also doing active copper. So they have the ability now using PAM4 in their DSPs to get 400 gigabits per second per lane on an optical link up to about, I think, 3 meter. So they're forcing they can force they're cutting edge on that. They also have the world's first 3 nanometer, 1.6 terabit per second optical DSP up and running.
Okay.
So it's their first 3 nanometer product, but it's part of this effort um, to lead in terms of high speed networking. And again, this technology is some of it going to be standard products, but they're also going to offer this to the hyperscalers to build their own custom solutions.
Well, and I can understand why they focus mostly on the data center. Obviously, the return on investment is significantly higher than some of the other market segments they're in. So, as we've seen with pretty much everyone else in the industry, it's data center, data center, data center, and AI,
Yeah,
AI, AI right now.
yeah,
And they're just coming off the AWS reInvent, where they announced a partnership, correct?
yep,
Yeah.
yep.
So.
Yeah, so it's all good stuff for them. They've got the 5 year agreement with AWS to develop custom silicon, and that's a pretty major. Hey, it's a big customer, but also a long-term commitment. 5 years is a pretty long-term commitment. One of the things that did come up, people did ask, you're doing custom silicon for these hyperscalers, but will they, is it one and done? Did it, how sticky is the business? And their response, the management response at Marvell was actually the business is pretty sticky. Once they're working with you and they've got that level of IP, they're happy with the results and you're performing and their IP, you know the business structure. It tends to be a sticky business. So once you have a deal, it doesn't tend to be up for grabs each and every 2 years or so. So it's
But is there an opportunity to extend this beyond the hyperscalers to the other cloud service providers or enterprise?
Absolutely. I mean, they've got a relationship with Meta. I'm
Hmm.
sure they are open for other hyperscalers. But it's still a competitive market
Hmm.
with Broadcom. Not Broadcom. Yeah, Broadcom. So
Broadcom.
that's their other biggest competitor. Probably more so than the standard products from NVIDIA, AMD, and Intel.
Yeah,
So
because they're doing the custom. This is really Trainium and all these other and Frenchia and all
yeah,
these other custom chips that they're doing.
yeah.
This is
Um,
great.
Yeah, they consider like NVIDIA like a friend enemy kind of thing. They work together, but necessarily they compete a little bit. But they still see there's absolutely going to be a market for standard off the shelf AI accelerators like GPUs.
Oh, I would completely agree.
Yeah.
So, any other key takeaways from the event you want to know?
Well, here's something that's a little bit different. Along the way during the Q&A, somebody asked Matt Murphy, the CEO of Marvell, what advice he would give to the incoming Intel CEO whenever that person is picked. And then he gave a long dissertation on his experience of turning Marvell around. He pretty much called it a dumpster fire when he got there. And now that they're humming along, if you look at their stock, it's sort of like taken off like a hockey stick up in the last year. And he's basically gave a long description of what he did and how he got deep into the company, and held meetings everywhere and talked to everybody, um, and really kind of got deep into the company culture and understood everything. So basically, he did a really good job uh, of building a resume for the Intel CEO job as well.
Nothing like marketing
But he said
yourself
he
for
was
the
happy.
next job.
I just don't know if he wants to go through the same experience he did with Marvell over again.
Yeah, Intel's a whole nother ballgame.
Oh,
That
it's a
would,
whole bigger ball game. Yes.
yes, that would be a challenge. Well, Kevin, this is for those of you who don't know, Kevin is retiring now, and I wish him the best. But
Thanks.
I wouldn't doubt that he'll be back in some capacity, or even maybe joining some of our webcasts in our TIRIAS cast in the future. So, Kevin, thank you very much for participating. If you're watching, please remember that our podcasts are available on our YouTube channel as
Mhm.
well as on SoundCloud, iTunes, and Spotify. Please like and subscribe. And if you have any comments or suggestions for future TIRIAS casts, please let us know. You can contact myself, Jim at TIRIASresearch.com, or my colleague Francis Sadeko at francis@TIRIASresearch.com. Thank you for joining today, and I hope you have a great weekend.
All right. Take care. Bye bye.